This is lesson 1-2, whole number operations. We'll be going over adding, subtracting, multiplying, and dividing whole numbers. For addition of whole numbers, you will perform the following steps. You will stack the numbers on top of each other, aligning the place values together. You will then add all the numbers of the same place values starting from the right, so starting from the ones place, and you must remember to carry the value of tens for any sum above 9. So here are some example addition problems. So for example, if it asks you to add the following numbers 39, 492, and 8, you will stack those numbers together. And a note for addition is that it does not matter the order in which you stack them. So I can stack them as they are listed. So I can start with 39, 492, and 8. So you'll notice that each of these numbers have a difference in number of digits. So 39 is 2 digits, 492 is 3 digits, and 8 is 1 digit. But the important thing is to align the place values accordingly. So I add 9, 2, and 8, all of them in the ones place, and that gives me 9 plus 2 is 11, plus 8 is 19. So that should give me a 19. And so when I have the sum of 19, I keep the 9 from the ones place of the sum, and I carry over the 1 into the place value immediately to the left, which in this case is the tens place. So now, originally I was only going to add 3 and 9, but because of the sum of the ones place is above the number 9, I have to carry that over, which in this case was a 1. So I add 1 and 3 and 9. So 1 and 3 is 4, plus 9 is 13. And finally, I would have normally just carried the 4, but I also had the 1 from the tens place of the sum of the previous place value column, and so now I have 5. So that number is 539. It says add 29, 38, 15, and 11. So again, I can organize them or stack them in the order that they provided them, or you can change the order. For addition, it does not matter. But if I add 9 and 8, that gives me 17. If I add a 5, that gives me 18, 19, 21, 22, and then 2 plus 1 is 23. Now you'll notice here that in this case, the sum of these four numbers was 23. So you keep the 3 from the ones place of 23, and you carry over the 2 from the tens place of the addition. So now, in the tens place, you move on to the next place value, you're going to actually now add 5 numbers. So you have 2, 2, 3, 1, and 1, and you get the sum of that. So 2 plus 2 is 4, plus 3 is 7, plus 1 is 8, plus 1 is 9, so you have 93. And that is addition. And so now we're going to move to subtraction. For subtraction, you'll perform the following steps. Very similar to addition. Of course, now you are finding the difference of numbers. Similar to addition's first step, you will stack the numbers, however, with the caveat that the number on top has to be the greater number. Then you will subtract the numbers from the same place value starting from the right, and then if the number on top is less than the number below, then you have to borrow as needed. So I'll show that with this example here. So it says solve for 245 minus 18. So I noticed that 245 is a greater number, and actually you will write it as it is provided. So in addition, you could write it in any order, but in subtraction problems, you will write it as they are provided. So here you have 245, and I am subtracting 18. Now, 5 minus 8, I can't subtract that and have a positive number. So what I will do is I will borrow from the place value immediately to the left, which in this case is the tens place. And for 245, I will borrow from the 4. And this 4 now becomes a 3. I am borrowing 10 from the 4 in the tens place, and I am going to add that 10 to my 5, and that becomes 15. Let's see if I can make it. There you go. So now it's 15 minus 8, and 15 minus 8 is 7. So I'm going to write that down. So now, before it was a 4, but I borrowed from it to do the subtraction in the ones place. So now it is a 3. So I am going to subtract 3 minus 1, and that is a 2. Now there is nothing to subtract from the hundredths place, so that just drops down to a 2, and the answer here is 227. A couple of addition practice problems. So for number 1, it says solve 27 plus 158. So I am just going to stack those numbers on top of each other, 27 and 158. 27 plus 158, so 7 plus 8, that is 15. I carry over the 1 from the tens place in 15. So now I have 1 plus 2 plus 5, and that is 8. And then there is nothing to add to the 1, so I drop it down, and it is now 185. That is the answer. Now, of course, in the GED test, won't usually be provided as simple as just add these numbers. You'll see more of a word problem set, and more commonly in further lessons and in the other subjects, addition and subtraction and all these operations are just part of solving the problem. So number 2 shows a different way in which you can see an addition problem, and it is, what is the total weight of the boxes shown? So unlike number 1, where it just told you add these, it's providing you different information and letting you know, hey, you will need addition to solve these problems. So to add the total weight of the boxes shown, I am going to take each number of pounds from each box and add them together. So I'm going to take 27 pounds, and then 12 pounds, and then 78 pounds. And so you would add the numbers, the values in the ones place, So you would add 7 plus 2, that's 9, plus 8 is 17. You add a 1 from the tens place of 17, so now you're adding 4 numbers. 1 plus 2 is 3, plus 1 is 4, plus 7 is 11. So you drop down the 11, so the answer is 117 pounds. So that is some addition practice problems. Subtraction practice problems. So here it says solve for 1,465 minus 49. So I am once again going to stack the numbers. And of course, subtraction has a caveat of the greater number has to go on top. So 1,465 is on top, and I subtract 49 from it. As was shown previously, I cannot subtract 5 from 9 and get a positive number, so I'm going to borrow from the place value immediately to the left. And this 6 becomes a 5, and this 5 becomes a 15. So 15 minus 9 is 6. 5 minus 4 is 1, and I drop down the 4, and I drop down the 1. So the answer is 1,416. So for the second practice problem, we have Julio's lunch costs $9. If he pays with the $20 bill, how much change should he get? I tend to find that when I'm having a bit of difficulty with problems in general, not just money problems, thinking of it in terms of money sometimes helps. It's something that we deal with every day, right? So even if the question isn't in terms of money, sometimes just thinking about it in that manner may help you figure out that problem. So he provides a $20 bill for a lunch that cost him $9, so he has $20, and his lunch cost him $9, so it's essentially 20 minus 9. Now you can, just count down with numbers that are that small, but going through the steps and the operation, you can't subtract 0 from 9 and get a positive number, so I'm going to borrow 1 from the 2 here in the tens place. This 2 becomes a 1, and this 0 becomes a 10, and 10 minus 9 is 1. And 1, nothing to subtract it to, so I drop it down, and it becomes that he should get $11 in change. Multiplication. So multiplication is really just a addition of the numbers a set number of times. So if I have the multiplication of 7 times 4, I'm really just saying that I'm adding 7 to itself 4 times. Or you can also do it interchangeably, where 7 times 4 means that you add 4 to itself 7 times. So either way works. You're doing either way, whichever is easier for you. But that is essentially multiplication. It's a short form way of saying, hey, add this number to itself a certain number of times. So here I wrote out the steps pretty much verbatim. of how to do multiplication. I wrote it down here just if you need a very written down way of performing the operation. And you see here it's 6 steps, and step 5 is to repeat steps. But really, once you start doing the multiplication, you don't even think about how you're doing it. It's just a certain set of rules which you apply from right to left, and you just carry that over, and it's done. So I'm just going to do this operation with the example problem here. So it says multiply 25 by 12. So I'm going to stack the numbers and align the place values. So I'm going to put 25 times 12. And just like addition, you don't have to stack them in the way that it's provided. You can also do 12 times 25 and it will give you the same answer. So you're going to find partial products. You're going to essentially do 2 sum problems to find the final answer, the product of the multiplication. So the answer to a multiplication product is called the product. So you'll find the first partial product by multiplying the ones place of the bottom number by the ones place of the top number. So that means that you're multiplying 5 times 2. And what did we say was that multiplication was? It's essentially 5 plus 5. And so 5 plus 5 is 10. So similar to previously, you keep only the ones place and you carry over the tens place in this case. So I'm going to carry over this 1. And now you are going to stay in the ones place of the bottom number, and you are going to multiply the ones place of the bottom number by the tens place of the top number. So now you're going 2 times 2, right? And 2 times 2 is the same thing as 2 plus 2, and that gives you 4. However, we carried over that 1, right? So now we have to actually add that 1, and that gives us 5. And now we drop the whole thing. And that means that we are now done with the ones place of the bottom number. So that is the first partial product. And now we're going to repeat those steps with the tens place of the bottom number with the numbers above it, right? So the first thing here is now I'm going to do this ones place, and I'm going to write a placeholder 0 here and for the second partial product. And now I'm going to do 1 times 5 here, right? It's supposed to be an arrow. And so now that is 5 times 1, or 1 times 5. And that's just really 5 by itself. So the answer here is 5. Next, you're going to do 2 and 1, 2 times 1, or 1 times 2, and 2 times 1. And that really is just 2 by itself. You don't add it to itself. It's just 2. So you'll notice here that any number multiplied by 1 is itself, right? So if I give you 4,096 times 1, that is 4,096. And this concept, I didn't write that correctly, but this concept is very important later on in many more math operations. Knowing that a number by itself is itself, a number multiplied by 1 is itself, is a very important concept that pops up in many other aspects of GED math and math in general. So going back to the problem, you now have 2 times 1, which is 2, so you just drop that down, and you are done finding the 2 partial products. So now you are going to add, it now becomes an addition problem with 2 numbers. So you're going to add as we did previously. So 0 plus 0 is 0. I'm going to put a plus here. 5 plus 5 is 10. I keep the 0 from the ones place, carry over the 1 from the tens place, and now I have 1 plus 2, which is 3. So the answer here is 300. So again, I'm not expecting you to memorize these steps verbatim or words. It's just practice multiplication problems, and you'll notice that the pattern just comes and you won't even think about the individual steps. So that is multiplication. Division. Division is saying how many equal parts an amount can be divided into. So if I look at this problem here, it says 24 divided by 4. What it's asking me is how many equal groups of 4 can you make out of 24? Now, in terms of division, in the problem 24 divided by 4, 24 is the dividend and 4 is the divisor. The answer of a division problem is called the quotient. So for division, it's a bit of a stepping process, and I color coded here. So in an example, as was shown previously, let's say it asks to divide 24 by 4. So the first thing you're going to do is rewrite the problem into the following format. So it literally looks as shown. So it's I've heard it called different things: the roof, the house, the hut. But you see a little half rectangle. It's the divisor on what is known as the outside, and the dividend as the inside. So if I write out that problem as shown, then the divisor is on the outside of the house, and then I have I'm just going to color code it to match it. I have the little house here, and then I have the dividend in the inside. So I have 4 divided by 24. So you solve this, but you solve the quotient, which is the answer to the division problem, by going left to right, by dividing the divisor by the place values of the dividend. So you're going to look at the divisor and try to divide it by first the 2 and then the 4. But notice that unlike the previous operations where you do go right to left, in this case you're solving left to right. So the question that you must ask is, how many times does 4 go into 2? Not how many times does it go into 24, just goes into 2. And the answer here is 0. Now you don't have to write the 0, and I actually recommend that you don't, but just for clarification in this problem, I'm going to go ahead and write it out. But essentially what you're doing is, well, it doesn't go into it any time. So 4 times 0 is 0. So 2 minus 0 is 2. So that's the first check, the first place value from left to right. Now I'm going to bring down the 4. And so essentially you're really just asking, how many times does 4 go into 24? And I'm asking what number times 4 equals 24. And in this case the answer is 6. So 6 times 24, 6 times 24, I'm going 6 times 4 is 24, and I subtract 24, and that gives me 0. When you reach 0 here, that means that you found a whole answer quotient for the division. And in this case, you don't need the 0 in the front, so the answer is just 6. And that is how you solve division problems. Multiplication practice. So let us solve this first number. It asks to solve 63 times 17. So I'm going to stack those numbers as they are shown in the problem. So 63 times 17. So multiplication again is finding the sum of two partial products. And to find the first partial product, you start with the ones place of the bottom number. So it is first 7 times 3. So I'm going to write it here, 7 times 3. And again, that is 7 added to itself 3 times, or 3 added to itself 7 times. But I find 3 summations to be better than 7, or easier than 7. So I'm going to add 7 3 times, and that is 21. I'm going to keep the 1 from the ones place of the 21, and I'm going to carry over the 2. Next, I do 7 times 6, which again is 7 added to itself 6 times, which is 42. And then I'm going to add the 2 that I carried over from 21, and that gives me 44. So the first partial product is 441. Now I am going to find the second partial product. I am done with the 7 of the bottom number. I'm going to add a 0 as a placeholder here. And I'm going to start with 1 times 3. So I have 1 times 3, and that is 3. 3 doesn't get added to anything, it's just 3. So I have 3 here. Next, I am going to do 1 times 6, and that gives me 6. So I add 6 here, and then I'm going to add the two numbers because I have found the second partial product, and I now have 1 plus 0, which is 1, 4 plus 3, which is 7, and 6 plus 4, which is 10. So the answer here is 1071. Now, problem number 2 is a word problem. It asks, or it states, a container of cooking oils holds 13 servings. If each serving is 5 ounces, how many ounces does the container hold in all? So, if it's 13 servings, each one of 5 ounces, this essentially is a multiplication problem of multiplying the number of servings by the number of ounces. Because if you have 13 servings at 5 ounces each, to find the number of ounces, you would essentially add 5 to itself 13 times, right? and that is easily represented by 13 times 5. So I'm going to multiply 5 times 3, and that gives me 15. I am going to keep the 5 from the ones place of 15, and I'm going to carry over the 1. And then I have 5 times 1, which is 5. And then I add the 1 that I carried over, and that gives me 6. So the answer here is 65. And that is multiplication. Now division. It asks, solve 132 divided by 11. So what this is asking me is, how many equal groups of 11 can I make out of 132? So I'm going to draw the little hut, or the little house, as it is sometimes called. And you'll notice that this 11 is a 2-digit number, so I'm not going to compare 11 against 1. I'm going to compare 11 against 13, or I'm going to ask against the 13. How many groups of 11 can I make out of 13? And the answer here is 1. And you'll notice that I wrote the 1, the quotient of the 1, above the second digit, because that's how many digits we're comparing. If it was only a 1-digit number and there was a number we could divide by the first, then I would write it over the over the first digit, but we're going 2 digits, so over the second digit. So 11 times 1 is 11. So I subtract 11 from 13, and that gives me 2. Then I drop down the next number, and I ask, how many times does 11 go into 22? And the answer here is 2. And 11 times 2 is 22, and I subtract those two numbers, and I get 0. So when I get 0 here, that means that I have reached the quotient answer. So the quotient here is 12. I can make 12 equal groups of 11 out of 132. Next, a word problem states, Carl has 16 pens. He shares all of the pens with his 8 friends. How many pens did each of his friends get? So we're going to start with 16 pens, and we're going to ask, how many equal groups of 8 can I make out of 16? Right? Now, this is a 1-digit to 1-digit comparison, so I ask, how many times does 8 go into 1? And the answer is 0. And as I've advised before, you don't write the 0 in the quotient, but you can if you want. Just remember that any leading zeros of a whole number don't factor into the value of that number, right? So 7 is the same as 7 with the 0 in front of it. And so since you don't need this, you don't have to write it. But it's up to you, whatever makes it easiest for you. So now my question becomes, how many times does 8 go into 16? And the answer here is 2. 2 times 8 gives me 16. So I subtract those two, and the answer here is 0. And when I reach 0, I have reached the quotient answer, and so the answer here is 2. The answer is, each of his friends gets 2 pens. And that is division. So that was whole number operations. Thank you for watching. So for subtraction, it follows a very similar steps count. Is